Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to learn some basic introduction about the periodic table, and we will also understand why it is important to learn periodic table and the elements of the periodic table. So let us first understand what people in the very ancient period used to think about elements. They used to think that the entire world is made up of four elements. Okay, who used to think like this? There were some Greek thinkers. Okay, in ancient Greece, there were some Greek thinkers. They used to think that the entire world is made up of four elements, that is earth, water, air, and fire. For that time, it was assumed to be correct, but now we know that all these four things are not elements. They are either compounds, molecules, or mixtures. But at those times, they used to believe that these are elements and the entire world is made up of these elements. Further, there were other scientists, they researched and they found out that these were not elements. And also there was some group of people, they were called as alchemists. They were called as alchemists. Now what were alchemists? Now we know that people who study chemicals, that elements and compound, they are called as what? They are called as chemists. Chemists are scientists who study elements and compounds. But in the medieval era, or you can say in the medieval period, there were some researchers who used to think that they used to believe in the mixture of science and magic. Okay, they used to believe a lot in magic. That is what is the meaning of the term mysticism. Mysticism or magic. Okay, that they used to believe that we can somehow introduce magic into science and create something interesting. What they did was they tried to convert ordinary metals like lead, we know it is Pb, lead, they tried to convert lead into gold. But they eventually failed, and we know why they failed, because these two elements are completely different and they cannot be converted from one element cannot be converted to another. Okay, so they failed completely. But in this process, what happened is they discovered some new elements and some processes that chemists still use today. So that was not completely useless. We learned some new elements from this process and some processes that we still use today. But was there any scientist who was brave enough to challenge this alchemist or prove that what they believed was wrong? So the answer is yes. There was a scientist named Robert Boyle who was the first person to understand that elements was the first person to understand the elements, and he proved by performing some chemistry experiments that whatever the alchemist believed was wrong. It was in which year? It was in the year 1660s, in the 17th century. He was the first person to prove that what alchemists believed was incorrect. So this was a short introduction of how elements were discovered, what were elements. Now let us try to understand why we should learn periodic table, why we should learn all the elements, what is benefit of, what do we get by learning periodic table, what is the benefit that we are going to get by learning the elements. So if we see our human body itself, it is made up of different elements, like 65% of it is oxygen. We know we inhale oxygen, and oxygen is a very essential element for survival. So we have 65% oxygen, carbon, hydrogen, nitrogen, and some other in very less quantity, phosphorus, calcium, and others. So our entire body is itself made up of so many different elements. So it becomes really important to understand the properties of these elements so that we can try to understand the processes that occur in our body, the different compounds and mixtures that are present in our body. To understand that, we must have a deep knowledge or in-depth knowledge of different elements. Another important thing is our atmosphere itself has different elements. In air or air mixture, you can say, air is a mixture of different gases, that is nitrogen, which is 78%, oxygen 21%, argon is 0.9%, and remaining gases are 0.1%. So our atmosphere itself is made up of different elements. So this is another important point why we should study elements. And using this basic knowledge of elements, we discover or derive, we form new compounds in the lab. Okay, we synthesize new compounds in the lab by studying the basic properties of these elements. Okay, so now let us try to understand how does a periodic table look like. Okay, so I have skipped a lot of history, we can study that later. So this is called as a modern periodic table. Okay, this is called as a modern periodic table. This is a periodic table that we follow now. Okay, there were some versions of the periodic table that were discovered before this, which we can discuss later. So now let us try to understand this periodic table that we use now. So this periodic table, it is basically divided into several groups or blocks. Okay, so before understanding the blocks, you can see that there are some horizontal rows. Okay, there are how many rows? 1, 2, 3, 4, 5, 6 and 7. So there are 7 horizontal rows. They are called as what? They are called as 7 horizontal rows. They are called as periods. Okay, there are how many periods? 7. And there are some vertical columns. These are called as what? These are called as vertical columns. And there are how many such vertical columns? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are total 18 vertical columns. Okay, vertical columns are what? They are called as groups. Vertical columns are called as groups. There are how many groups? 18 groups. Okay, 1 to 18, this is the new nomenclature. If you see, there is some things that are written in Roman numeral. Sometimes this is also used as a name for the groups. 1A, 2A, 3B, 4B, 5B, 6B, 7B, 8, 1B, 2B and so on. Okay, 3A, 4A, 5A, 6A, 7A and 8A. This was the older nomenclature of the groups. So this was a basic information about the groups and the periods. Now, based on this color code, you can see the first one, this group 1 is called as alkali metals. Group 2 is called as alkaline earth metals. This we'll see in detail in a moment. Then there are transition metals, basic metals, semi metals. So you can see majority of the elements in the periodic table, they are what? They are metals. Only a very few of them are non-metals. Okay, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium. Okay, these are what? These are non-metals. And there are very few halogens: fluorine, chlorine, bromine, iodine, acetylene, tennessine. Okay, and there are noble gases, lanthanides and actinides. So we will see in detail what are the names of these groups and also the different blocks. So now let us try to understand what are the different blocks of the periodic table. Blocks of the periodic table. So you can see group 1 and 2. Group 1 and 2, they are called as what? They are called as S block. Why they are called as S block? Because a valence electron or the outermost electron is filled, last electron goes into the S orbital. That is why it is called as S block. Then from group 3 to 12, okay, group 3 to 12, as you can see here in this periodic table, group 3 to 12, this middle portion, the blue ones, they are called as what? They are called as D block or transition metals. Okay, that is the D block. Then from 13 to 18, this last block, you can see this is called as elements from 13 to 18, groups 13 to 18, this is called as P block. And there is one last block which you can see at the bottom of the periodic table. Okay, that is called as the F block. Okay, so there are 4 blocks in the periodic table based on their properties, chemical properties: S block, P block, D block and F block. In S block, the outermost electron enters the S shell. P block, it enters the p orbital. The last electron or valence electron enters the p orbital. Similarly, for d block it enters the d orbital, and for f block it enters the f orbital. So these are the 4 blocks. Now let us see one by one what are these elements called as. So first is a group 1. Group 1 is called as the alkali metals. As you can see here, it is written alkali metals. Okay, along with the group names of the groups, we'll also try to understand the names of these elements, so it becomes easier to understand. This is what lithium, sodium, potassium, rubidium, cesium and francium. This is group 1 elements. They are also called as alkali metals. Next comes group 2. Group 2 elements are called as alkaline earth metal. Alkaline earth metals. Okay, what are the names of these elements? Beryllium, magnesium, calcium, strontium, barium and radium. So these are the group 2 elements. Group 1 and group 2, they constitute what? They constitute S block. Now let us see, these are the transition state elements. Okay, these are called as transition elements. Transition elements, or we can also call them as metals, because all of them are metals. And why they are called as transition? Because they are transitioning or change, there is change in the properties from S block on moving from left to right, that is from S block to P block. Okay, there is change. Transition means change. Change in what? Change in the chemical and physical properties. Transition is change in the properties. Okay, what are the names of these elements? Let us quickly see that. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, yttrium, Zrs, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, HF is hafnium, tantalum, W is tungsten, this is rhenium, osmium, iridium, platinum, gold, Hg is mercury, RF Rutherfordium, Db is dubnium, Sg is seaborgium, Bh is bohrium, this is hassium, Mt is meitnerium, this is darmstadtium, Rg is roentgenium, Cn is copernicum. So these were the transition metals. Next we come to the P block. Okay, in P block comprises of how many groups? 13, group 14, group 15, 16, 17 and 18. So now we are seeing group 13. Okay, this is called as boron group. Why it is called as boron group? Because the group starts with boron. So boron, aluminium, gallium, indium, thallium, nihonium. Okay, these were the group 13 elements or boron group. Next is group 14. It starts from carbon, so it is called as carbon group. Carbon, silicon, germanium, tin, lead, flerovium. Okay, so this is also called as carbon group or carbon family. Next is group 15. Okay, this is group 15. Now group 15 elements, they are also called as pnictogens. P silent. They are called as pnictogens. What is the meaning of pnictogen? Pnictogen means to choke. Okay, or cause suffocation. Okay, how do you get this name? This name is based on nitrogen. Okay, whenever there is absence of oxygen or there is excess of nitrogen, we suffocate or we choke. That is why this is called as pnictogens or nitrogen family or nitrogen group. This is group 15. Okay, remember this name because sometimes an alternate name is used rather than simply group 15. Okay, next is group 16. It is called as oxygen family or it is also called as chalcogens. What is the meaning of chalcogen? Chalcogen means ore forming. Oxygen, you can see oxygen is present in the form of oxides. Okay, oxides in many ores. in many ores you can see oxygen is present in the form of oxides. Okay, that is why it is called as ore forming, based on the name of oxygen, which is present in many ores. Okay, because several metals, they easily react with oxygen present in the atmosphere to form oxides. Okay, so group 16 elements, they are called as what? They are called as chalcogens. And okay, we didn't say the name of this. Name of group 15 elements: nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. Okay, group 16 elements are oxygen, sulfur, selenium, tellurium, polonium, livermorium. Okay, next is group 17. Okay, group 17 elements are the most electronegative elements. Fluorine is the most electronegative atom. Electronegative means electron withdrawing atom. Most electronegative element of the periodic table. Okay, this is group 17. These are called as halogens. Okay, what are the names? Fluorine, chlorine, bromine, iodine, astatine, tennessine. And next, this is the last group of the P block. This is called as group 18. Now, group 18 elements are supposed to be very, very stable. Okay, very stable, and they generally do not react. Okay, they generally do not react. But the higher atomic mass elements like xenon can form some compounds. It is known that xenon can form some compounds, although they are stable. Why? Because the size of the xenon is very large. Since the size of the xenon is very large, the outermost electron are loosely bound. Okay, so they can easily form bonds. Okay, they are loosely bound, so they can react. So there are some compounds of xenon and fluorine like XeF6, xenon hexafluoride, and many other compounds of xenon are known. So these are what? These are called as noble gases. Okay, why they are called as noble gases? Because they generally do not react with any other compounds. Okay, so this was a group 18. Now we come to the last F block. Okay, F block has two sets of elements. One is called as lanthanides, another is actinides. Okay, what are the names of this? Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. And actinides are actinium, thorium, protactinium, uranium, neptunium, plutonium, americum, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and lawrentium. Actinides, you can see most of the actinides are what? They are man-made and they are radioactive. Okay, radioactive. We will see in detail about each and every element. Now everything is fine about the names of the elements, their classification and all, but how does these elements exactly look like? So this is a small glimpse or look of how these elements look like. This is a chunk of yttrium. Okay, this is silver. Okay, this is obviously impure silver, which is oxidized, and that is why this is dark brownish in color. Okay, actual pure silver, we know it is very shiny and lustrous. Silver, zirconium crystal, barium crystals, this is selenium, magnesium crystals, osmium pellet. Then we have nickel balls and cube of melting gallium. This is very interesting element. Gallium has a very low melting point of almost same as that of the room temperature. So it exists as liquid. It melts very quickly. In room temperature, if you see gallium, it exists as a liquid. Iodine is a solid, but here they have put it in a glass sphere. It is purple in color, bluish purple. Then we have uranium. It is highly radioactive in nature. Then we have gold crystals, thallium, calcium crystals. So this was a glimpse of some of the elements, how do they look. And in the coming videos, what we are going to see is, we are going to understand the chemical properties. We are going to understand how do they look, whether it is a solid, liquid, gas, what is their color, what do they exist in, how do they look in room temperature, and very important, their applications. Okay, where do we get to see these elements in day-to-day life? I hope you have found this video useful. Thank you.